So this is the Athabasca University Geophysical Observatory. It's located about a half hour west of Athabasca. The place is special because it's in an area that doesn't have very much light pollution, so we're able to see really clear skies of the aurora, and we're at a higher latitude than a lot of other places, so we get more aurora. It's also quiet electromagnetically. There's no power lines or anything, so it's good for measuring magnetic fields, electric fields too.
Well, there are practical aspects to studying auroras. One is that they are known to have caused power failures.
When there's a strong solar wind coming from the sun, hits the Earth's magnetic field, causes it to bend and wobble in some very complex ways. When there's a changing magnetic field of the Earth, that's going to induce a current in the ground. And that's primarily what I both measure and model with my research. The risk is that you get these unwanted currents in power systems, and that can cause problems with the transformers in power substations. It can cause heating, it can cause voltage irregularities on the grid, or widespread damage to infrastructure. And the really big concern is that you might have a widespread outage.
There are secondary aspects not quite directly related to auroras, but they come in our entire study of space weather, such as you can lose communication with airplanes over the North Pole. You might recall that there was a few years ago a loss of about 20 satellites newly launched, and a solar storm came along and affected the atmosphere. The atmosphere in turn affected the satellites, and down they came. So there are many practical aspects to this field that we call space weather. The real test of knowledge would be if we could do good prediction.
That's kind of the holy grail, I would say, is if you could give them a prediction, 5 or 10 minutes in advance, that really helps for these sorts of things. We're not quite there yet, but we do have the ability to model electric fields in Alberta in real time almost now, and we can again validate it with these real-time continuous measurements as well.
There are definitely real-world applications for what we do. It's beautiful and it's scientifically interesting, but it's also important. Our studies of so-called space weather have a very strong practical side to them.